Ryan, can you do me a favor and get the first two blinds, please? Or shades, whatever. I think there's pretty bad glare.
And you're going the wrong way.
Gotta set up the lighting. Yes, the mood lighting.
Ring light.
Cue jazz music.
I read that whole problem to you, and you just wrote that.
That's all I needed. So, I did exactly what I don't want you guys to do. When you're reading these problems, I want you to read the entire problem, then the question, and then go back and pick out numbers you need. And you'll get used to it, hopefully, by the end of the period. Your homeworks are going to be more of these. Tomorrow we'll go over the homework. I'll give you another sheet. So you have 2 homeworks on this stuff. We'll go over that, and then that's it. I'm not going to spend any more time on it. So today's the most important day, is where I'm teaching how to do these problems and how to solve these. So this is the combined gas equation, or combined gas law. When you have a problem like the one in your notes there, and it says constant temperature, what does that mean? It means temperature is not changing. So therefore, they don't give you one. So if you read the question over again, there's no temperature. So, and I know I said this yesterday, but it was at the end, so I'm just reviewing. So T1 and T2 are non-existent in this question. There will be questions we do today where you have to use all these variables, but right now, all we need are these 4. So this equation turns into just P1 times V1 equals P2 times V2. So that's an important, oh, it's more like a Q, but that's an important skill that you understand when you're reading a question on gas laws. Sometimes, often, they hold one of the variables constant. So we know how all these react together. We're going to learn in lab. When I say react, I mean how they affect each other. Pressure goes up, volume goes down. Temperature goes up, volume goes up. Temperature goes up, pressure goes up. So we're going to practice that in lab too. But in this problem, we don't care about temp. So we only want to see how pressure and volume are related. So in lab today, those of you who had lab today, you saw when you put the mass on the syringe, what happened to the volume? Decreased, shrunk, right? You squished it. So if my volume in this problem is going from 1.5 up to a 3.0, would we expect our second pressure to go up or down? If the volume went from 1.5 to 3,
Down.
think of the syringe. Would we want more pressure on top or less?
Less.
Less. Inverse. So this type of equation shows an inverse relationship. You don't need to know that, but that's what's going on here. So how do we solve this problem? Well, the way I suggest doing it is over on the margin or somewhere underneath it, you label everything they give you and everything they don't give you and what you need to solve. Some of you may not have to do this, but humor me at least for the first couple examples. Get this down in your notes. So under the problem, label P1, V1, P2, V2. I don't have any temperatures because it's constant. They didn't give me any numbers, so I can't use it anyway. So now I go back to the problem, and as I'm reading, the way you decipher or determine your 1s and your 2s, your 1s are the initial conditions, then some kind of change happens. Heated, cooled, expand, compressed. You're going to see some word that says heated, cooled, compressed, expanded. Those are the biggest ones I can think of, the most common. But something's going to happen to the gas, and then there's the after. So your initial is the 1, something changes, then the final or the after conditions, that's the 2s. So initially it said we have a pressure and volume of 1.5 liters and 101.3 kPa. So my P1 is 101.3 and my V1 is 1.5. And if you want to label units, you can. I'm not a huge fan of putting units in calculations, but I am a fan of units after the calculation. So it depends on how you do with these things here, but if you want to keep the units the whole way through, maybe that's better for you. But at the end, your final answer, you definitely need units or else you'll lose points. But they don't have to be shown in the calculation itself. All right, so now it says what? Allowed to expand, right?
Yeah.
Do me a favor and circle or underline that. Just humor me here. Some of you may get this quick, but go with me anyway. underline allowed to expand or circle it, whatever. Why am I highlighting that?
That shows you the pressure.
That's the change.
Bigger?
Right, that's the key word, that's the change. So when you're reading these problems, there's going to be a change from initial to final conditions. I want you to be aware of that. Any number before that, that's your ones. Any numbers after that change, that's your twos. The biggest problem I've seen over the years, kids tell me, is I don't know where to put the numbers. So I'm trying to do a better job here the past couple of years explaining there is a change in the problem. Before that change, that's your ones. After the change, that's your twos. So if you underline or highlight the change, heated, compressed, cooled, expand, that really helps you separate where the numbers go. Now we label, before we plug them in, we label where they go. So 3 liters is the second volume, 3.0. Now the question asks, or says to calculate what?
The pressure.
The new pressure. That's P2, so that's going to be a question mark or an X, whatever you want to use there. We're going to put an X in the equation, but that's what we're solving for. It always surprises me, not always, but often, kids will set everything up right, plug all the numbers in, they'll solve it, and then they have no idea what unit to end or what to put on their answer. And the only reason I'm saying it surprises me is because the units are in the problem. You just have to go back and say, all right, well, pressure is kPa, oh, it must be kPa. Or volume is liters, it must be liters. So maybe that's not so obvious, so I shouldn't kind of be a jerk about it, but sometimes I get frustrated because it's right there. You just have to go back and look at it. So in this problem, pressure is kPa because it already gave you one of the units. You don't have to just make it up or guess. They'll always give it to you, you just have to go back and find it. All right, so we're solving for P2. Can anybody plug these numbers in here, set it up for me? Again, some of you can go quick probably, but I'm going slow on the first couple here, so stay with me. So who can substitute these numbers in here correctly? Go ahead.
Alright, so you do 0.13
Yep.
times 1.5
Yep.
equals question X
Yep.
and 3.
3.0. Very good. I use parentheses for multiplication. I don't use the X because X's are variables. I find that confusing myself. You can use dots maybe for multiplication, but typically you'll see parentheses. And when you take physics, Mr. McConnell uses parentheses as well. All right, how do we solve for X? Again, we're going to go nice and slow in this first example. What do we do?
You have to multiply first.
Multiply
The parentheses.
which ones?
You have to multiply the 103 times the.
Right, 101.3 times 1.5. Someone do that and tell me what that number, 151.95?
Mm-hmm.
Okay,
Yep.
equals X times 3, so that's the same. 3X, well yeah, I'm just going to leave it like, it's just the same. So now what do we do?
Now you
Divide by 3 to get the X by itself. Divide by 3.0, that cancels out. Now we divide 151.95 divided by 3 there.
50.65.
And yeah, give me, well, I didn't do this right. The next problem I give you, I'll do sig figs. I don't want 2, that would be too much rounding. So technically, this should be 1.50 and 3.00, so I get 3 sig figs. So go ahead, say that again with 3 sig figs. 50.7. It was 6.5, so 7. All right, 50.7. What's the unit?
KPA.
KPA. Circle it. So everything I just put on the board is what I need you to do on your homework due tomorrow. Once I give it to you, you need to show me your work, and then final answer with unit, circled or box. Box or circle your answer. Yes, sir.
Do we have to do the P1 equals?
You don't have to do this. You can jump right to the work. Does that make sense? Like showing me the equation doesn't get you any points on a Regents. It's plugging the numbers in, showing work gets you a point.
This is.
So, the rule about sig fig, actually, can anyone remember? What's the rule about sig figs? Why is this 3?
Because it's the one with
Because
the.
you start on the Pacific when you're the decimal.
Well, I think we all get that. I mean, how do we know to round it to 3? Paul, he has hand raised.
The smallest non-sig.
smallest number of sig figs in the problem. This has 4, 3, and 3, so we gotta go with 3. Yeah.
On the regions, are these usually like multiple choice questions or?
Yes.
Alright, works for me.
No.
Oh.
You know, I would guess it. I would say it's probably about a pretty good mix. Sometimes short answer. Which would you prefer?
Multiple choice.
Why?
Because then I know like if my answer's not an option, then it's wrong. If it is.
So let's say you do all this work and you get, I don't know, 60.
Yeah.
And you look at the multiple choice, 60's not there.
And I know
Do
I
it
did
again.
something wrong.
We're wrong.
I know something's wrong.
Okay, so then how does it help you get it right though? You go back and figure it out?
It tells you it's wrong.
Because you know your
You're
answer's
right.
not there, so it's like, well, I did something wrong.
Or if you really just like are stuck and you're panicking, you just genuinely
Just guess.
can't care anymore.
I just-
Just
you just
say
say what you
and
know.
you tried.
Yeah, then you start.
Well, I'm glad we're having this conversation. So,
Good.
if it's short answer, you always get points for work. So that's like just a gimme basically. As long as you plug numbers in, you'll get at least 1 point for that. So that's from my perspective, that's good for short answer. You also get points for units sometimes, so that's good. But back to your multiple choice. All right. So let's say you get the wrong answer because it's not listed, and you're starting to get frustrated. And like Morgan, she just doesn't care. She wants to guess.
Wait. But also, what, like, oh, I don't know if everyone else does this, but if I'm just like sticking to that answer, I'll choose the number that's closest
Closest
to
to
it.
it,
that's what I do too.
Yeah, I mean that's not really good logic, but I get why you do that. Yeah. Well, anyways, but there is one thing you can do on a multiple choice. You look. Let's say you get 60. And you look and it's not there. Well, if you remember the concept, all right, and this might be me stretching a little bit because if you're at that point mentally on a test, you might be doomed already. But what's the concept here? Well, Boyle's law says if the volume goes up, the pressure must go down. We already talked about that. So if maybe 2 choices were above 101.3, you could eliminate them.
Yeah.
So that is another advantage of a multiple choice. If you get the concept and you know your answer is supposed to be lower than 100.3, 101.3, so if you know that at least, then maybe there's a choice or 2 above that, and you're like, well, that can't be right because the volume's getting bigger. But I'm stretching that because usually students who pay attention to that will know how to do the math, and you'll be fine anyway. And this whole conversation is pointless because you're all going to be good at this by the time we're done anyways. Right? Right.
I
All right.
can hear him. I feel you out.
So that's how we do this problem. Let's do another one. That's using just P and V. I'm going to do one differently this time. We'll hold another one constant. And I'm going to give you a few minutes to see how you do on your own. Then I'll go over it. All right, so here's the question.
It's not really dumb question, but I figured it out.
A sample.
Do we have to write
Oops.
that down?
Yep, you have to write the question down. A sample, pick a guess. Anybody? What is it?
Chlorine.
What did Stavros say?
Helium.
Here's the first one. A sample of helium at STP is heated in a rigid container to 400. I don't like that number. 452 Kelvin. Assuming volume is held constant, calculate the new pressure. When I said rigid container here, don't underline that. Because that's not the change. I want you to underline and circle the change. But I'm underlining rigid container. That's more of an AP thing. They won't tell you volume's held constant in college chemistry. You have to figure it out. Rigid container means like this water bottle. That thing's not expanding. So if you heat up a gas in there, pressure's just going to build. It might blow up, but the volume's not going to expand. It's not going to change. That's what that means. But on a Regents, they will tell you volume is held constant, volume remains the same, volume doesn't change. They will say something to help you out. So there's another example of a gas law question. I kind of went to a little bit of a hard one here. you're using the combined gas law. I'll give you a little bit more direction, then I'm going to give you a few minutes to work on this. Volume's held constant, what does that mean for the equation?
Same.
Right, so the P1 V1 over T1 equals P2 V2 over T2. What does that mean?
There's no V.
There's no V. So take the V right out. You don't need it.
What's your temperature?
Ah.
Oh,
So, I'll give you two more hints, then I'll stop talking. Where's the change? What are you circling or underlining?
heated.
Heated, good.
There is an increase.
Everything before that word, that's your ones. Everything after that, that's your twos in the equation. Last thing, here's my last hint, and continue. This right here tells you some information about the
I don't know
ones.
what that means.
All right, I'll give you some time here, walk around, see how you're doing, then we'll go over it. And feel free to help out your fellow classmates if they're confused about STP.
Me too, Paul. Possibly. Neighbor, friend, pal. You know, we don't just sit next to each other here, we sit next to each other at lunch. That means a lot.
Thanks so much.
So you're showing your work, solving for the new pressure.
Thank you.
See how we do here. I have high hopes for this class, right?
That's so nice.
We're all going to get mastery on the regions. I hope.
That is the first time that that's ever happened to me.
It was the first time it ever happened to me that entire class would get
Is
that.
that the P?
But you know what? Why not this year?
Oh, yeah,
Right?
yeah.
Why not? You guys are as good as anyone.
Wait, just like write it down or like the equation?
Bet.
Oh, okay.
That's nice.
I like your eating habits, Stavros. What? You're on that weight one.
Oh, that's supposed to be one.
Stavros.
That's supposed to be one.
No, I said Stavros in his eating habits. Oh, eating habits.
I have to start eating
I said
healthier
Stavros.
because it's almost hospital season and I don't want to have a shape.
Canceled. Canceled.
Some of you have the right numbers, others I still think are confused. Can
Yeah.
anyone in the class tell everyone where to find STP? Reference table what?
Oops.
A,
That
reference
was
table
not
A.
Here you go. Yeah, right here. Helium.
Morgan.
Oh, here, right here. What did I do?
I don't know.
Whoa,
Don't ask me.
cool. Oh, we saw it.
And I want sig fig rules applied here
Good job, guys.
on your final answer.
Hold on.
Okay, now go to table A.
Okay, so.
So
one
this here,
over
I gave you a hard one. This
Over.
STP is standard temperature expression. That's what STP stands for. So if I say you have a sample of gas at that means they're at these numbers.
It's the one with the least amount.
Oh, I made a mistake though.
Oh, thank goodness.
Anyone?
I can do this.
Paul.
I didn't tell you which pressure to use. So you can use either one.
Disgraceful.
Sorry.
Well,
I should have told you which unit to use, KPA or ATM. You can use either one.
I did that part right.
Doesn't matter. Use either one. Still learning the same thing. It's okay to yours.
the same answer?
On a roll now. You know what numbers? No.
I know what numbers.
Because one is 1 and one is 1.3. Right. But they both could be correct. It just depends.
That's another big number. Sometimes.
You got a big number?
Ella.
So did we do anything else?
Everyone listen up. Ella's got the answer here. No, not the number. So Ella, if we're heating a gas in a container that can't expand or compress, what's going to happen to the pressure? It's going to go up. So your answer for P2 better be larger than P1. Otherwise you did something wrong. Because this is Lusak's law. You heat it up, pressure goes up with it. It's got to be bigger than P1.
Okay, I think I got it.
I don't know.
That looks good. Set up. Yes, sir.
What did you get?
I got 1,000.
An 18? That's what I got.
Yeah, so the rule, you wanna keep it throughout,
I think we're right
some
there.
calculations in advance. Steps. So the rule is, you can either keep as many unlimited through the steps, or add one. So like if you have 3 or 4, then it'll be 4 or 5, and then when you get to the end, you go back to the original scenario, and then, but in your steps, you can keep as many as you want, or at least add one, just to make sure you have accurate numbers.
Yeah, no, 'cause that was a big number, yeah.
Right, because those numbers are so big, that would be silly to try and round it to 3.
218?
That's what
Just,
you're asking.
That's what I got.
Yes.
I think that's right, 'cause everyone's like, the number's really, really large, and I just got like, oh, it's like.
Well, let's see, what's your starting pressure? Feel free to talk to somebody around, take a minute or two, compare answers,
I'm
discuss.
embarrassed by my answers, so.
What was your original pressure?
Oh, I got like.
That's your 10.
Hey.
Oh, okay.
I have to do this on purpose.
Oh,
This is it.
Oh, what did you
Do it
do?
again, right now.
I
We
already
can
did
go
it.
to another page.
Daryl, we did
Wait, I got
something wrong.
106. I think I just put in a number wrong, because I got like the same portion.
Yeah, I did something wrong.
Yeah, I'm gonna give one more example, otherwise.
Wait, actually, just.
So I'm gonna give you 1 minute here.
What are you doing? Did you get number? That's completely wrong.
I mean, so I was always rounding, so I probably don't know.
Something's not right.
So as I walk around, the mistakes I'm seeing is not the numbers. It's where you put the numbers. So it's really important, eyes up here,
I expected that.
really important that you understand that this equation cannot be manipulated and you have to put the numbers where the numbers go. What does that mean? Well, first of all, there's no volume. Y is held constant. So we're really only dealing with P1 over T1 equals P2 over T2. Some of you don't have division symbols. You have just all multiplication. And that's right. You're learning. You're making mistakes. Fine. Whatever. That's why we're doing this in class, to learn. So here's what I suggest you do. Once again, P1, T1, P2, T2. And then take your numbers and plug them in to the equation. I think some of you are skipping some steps, trying to do too much in your head, and it's just too much to keep straight. So I really recommend most of you, if not all of you, doing this kind of slow in steps. So you're reading it. Heated is the change. It was heated. In a rigid container, 2452. All right. So now I'm gonna go back. My P1 and T1 must be before this word. That's right here. Now, did we all use KPA? All right. So P1 is 101.3 KPA. T1, it's got to be Kelvin. If you use Celsius, you have to convert it. All right, I think the homework I had you converting a little bit. So if it's Celsius, you got to convert to Kelvin. I talked about that yesterday. It's directly proportional. There's no negatives, no zeros. You couldn't have 0 Celsius. That would be crazy, right? Because then you would have 0. That doesn't make sense. So it's got to be Kelvin. Now, 452 is after the change. So that's my T2. And my P2 is X because the question is asking me what is the new pressure. So that's half the battle right there, is just figuring out where to find STP and then where to put these numbers. Questions? All right. So now it's easier for me on a whiteboard because I can just erase. But P1 is 101.3. Everyone pay attention. Stay with me. Eyes up here. T1, 273. P2 is my X. And then T2 is 452. So the way I just did this is exactly how I recommend all of you doing it. Write down what the variables are, what you're looking for, then substitute it in. As you get better, you can go right to the substitution. But I really would do this first. Now we cross multiply. Someone take 101.3 times 452. Raise your hand and tell me what that number is. Ready? 457.8.6. 273 times x. Now what do we do? Divide by 273. Divide by 273. 3 sig figs is going to be the final answer. 4, 3, and 3. So raise your hand. Tell me what you get for that, Tara. 169. 168. 168 kPa. Circle it. Box it. That makes sense. If temperature goes up, pressure is going to go up because the volume can't. It's in a rigid container.
Figured out what I did wrong.
Questions? So, we're done with notes. Here's your homework.